Good morning, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to deliver about the topic Frequency Division Multiplexing, FDM. In analog multiplexing, the most used technique is a frequency division multiplexing. So this technique, which uses a various frequency to combine streams of data for sending them on a communication medium as a single channel. Example is a traditional television transmitter which sends a number of channels through a single cable, uses the frequency division multiplexing. In frequency division multiplexing, number of channels will be there which are combined and transmitted. Data is a number of channels are combined and transmitted through the multiplexer, and in demultiplexer again it will be get separated. So we will be having a multiplexing and demultiplexing here. So how does FDM works? A number of signals will be transmitted at the same time, and each source can transmit a signal in an allotted frequency. So there is a suitable frequency gap between the two adjacent signals, so that this in turn avoids the overlapping of a signal. So each and every signal will be allotted a particular frequency, and the signals will be transmitting the particular signal in the allotted frequency. So number of signals can be transmitted at the same time. Since the signals are transmitted at allotted frequency, it decreases the probability of a collision. Overlapping and collision is being avoided. The frequency spectrum is divided into several logical channels in which every user feels that they possess a particular bandwidth. A number of signals are sent simultaneously at the same time, allocating separate frequency bands or channels to each signal. It is used in radio and TV transmission. Therefore, to avoid the interference between two successive channels, guard bands are also used. So this is a block diagram for FDM transmitter and FDM receiver. So the signal will be passes through the different modulator. For input to the modulator is one of the input is signal, other input is a carrier signal, which are linearly mixed, and the output is a composite signal which passes through the channel. On the receiver side, FDM receiver, the composite signal given to as an input to the band pass filter, it separates a particular band of frequencies, and it is given to the demodulator, and it will be getting the output as a required signal which is being transmitted. So FDM transmitter, numerous signals that are being transmitted along a common channel modulate the different carriers in the modulating section. The output of modulator will be having a multiple signals of different carrier frequencies. The modulator signals are then fed to the linear mixture, which is different from that of the normal mixture. Linear mixture simply produces the algebraic sum of generated modulated signal. The combined signal at the output of the mixture is then transmitted along a single channel. In case of the receiver station will have a composite signal that was transmitted by the linear mixture over the channel. This composite signal is then fed to the different filters. Mainly it is a band pass filter, each have a center frequency corresponding to the carrier frequency. The band pass filter passes the channel information without any distortion. Band pass filter rejects the signal of other frequencies and accepts the signal of desired center frequency. So further, the signals after being processed by the band pass filter goes to the individual demodulator section, where demodulation of a signal takes place to separate the modulating signal from the carrier signal. So after demodulation, we can have a separate signal that is nothing but the signal that is actually being transmitted over the channel. Advantage is that efficient use of the bandwidth. FDM allows multiple signals to be transmitted over a single communication channel, which can lead to the more efficient use of available bandwidth. No time synchronization is required. FDM does not require precise time synchronization between the transmitting and receiving devices as did we had in a time division multiplexing, making it very easier to implement. Low implementation cost. FDM is relatively simple technique that does not require a sophisticated hardware and software, making it less expensive to implement. And drawback is that limited capacity. FDM is limited in terms of number of channels that can be transmitted over a single communication channel, which can be a disadvantage in applications where a number of signals need to be transmitted. Interferences. FDM can be susceptible to interference from the other signal transmitted on nearby frequencies, which can degrade the quality of a transmitted signal. And difficulty in assigning frequency. FDM requires careful assignment of the frequencies to different signal to avoid the interference, which can be a complex and time-consuming process. Application is concerned, in the first generation of mobile phones, FDM was used, and use of FDM in television broadcasting is done, and FDM is used to broadcast the FM and AM radio frequencies. And that's all about the process that is involved in the FDM in transmitter side and the receiver side, and what are all the advantages of FDM and what are all the drawbacks of FDM, and where this FDM technique was used. Thank you.